we also need to be careful at the end. We need to check our answer and make sure it works. Or at the very least, look at this. Can you tell me what x cannot equal right now? 1, because it would make our denominator 0. Okay, so then our strategy is to multiply and get rid of our fractions. So to get rid of the first denominator, we would have to multiply by a 2. That cancels this one. What else do we need? X minus 1. So that gets rid of those. The next step I usually do, just to kind of clean up my work a little bit, so I'm left with 2x minus 3 times my x minus 1. I have a 2x times 2. And over here I have x times, you could go ahead and distribute 2x minus 2. Alright, so I just wrote out what I have left to multiply. How do I multiply those first ones? FOIL, that's where I got to here. 2x times 2, give me a 4x. And I multiply that one out for you, 2x squared minus 2x. Because you're taking 2x minus x. Alright. So now what? We need to kind of combine my terms, get everything on one side so we can solve this. We may need to add another line in here, but if we just combine, we have a 2x squared minus x plus 3 equals 2x squared minus 2x. If I subtract my 2x squared, what happens? Those are gone. If I add my x over, I have, I need another line, 3 equals negative x. So then how do you find x? Divided by negative 1, so x is negative 3. Okay, how do you check them? Plug it back into the original. At the very least, you need to verify that you aren't going to get 0 on the denominator. So is my answer okay? Yeah, the only thing I couldn't have is 1, so 3 is okay. But if it were a test or quiz, I'd probably take that time to make sure I hadn't made any other mistakes and plug it in and check. Alright, so that's our strategy for a rational. Are we okay with that? I was just getting ready to ask you, is it just today?
No, it's just have probably.
Okay. All right, radical equations. So something with a cube root, square root, something like that. Our goal, we want to get rid of that radical. To do so, we have to isolate it and then use a power to get rid of it. So on this one, what would you do first? Add the 2 over. All right, if I want to get rid of a cube root, what would I have to do? Cube each side. Cube root and a cube cancel, so I get 2x minus 4. 2 to the third power is, add over my 4, I get 12, so x is 6. But we always check here. You can work it out by hand, you can plug it in the calculator. If I put in 6, I get 12 minus 4, which is 8. Cube root of 8 is 2, minus 2 is 0. So it does work. The back side. Based on the questions I've been asked today, substitution is what we have struggled with the most. So I am going to force you to do this one by substitution, then I'm probably going to throw another one up here to do by substitution. So, if I wanted to solve this, I have to look. I have something squared, that same thing to the first and a constant. So it is like a quadratic. The substitution, it really isn't changing the problem, it's just making it easier to look at, so it's more like what we're used to. So you pick your favorite letter, I usually use a U, and it's going to replace this thing. So it is going to be my x plus 2 here. Alright, so my problem started out x plus 2 squared, but I'm changing that to a u, so it's u squared. Plus 11, x plus 2 becomes u. Minus 12 equals 0. What multiplies to negative 12 and adds to positive 11? Positive 12. So if we solve u is 1, I'm going to get a 12. Okay, but my original problem did not have u. What was the u? Okay, so x plus 2 can really equal these things. X plus 2 could be a negative 12 or a positive 12. So solve, and we get negative 14 and negative 1. And then what should you do at the end always? Check. Do you guys all know how to plug them in your calculator and check? These do both work. We didn't get any extra answers here. All right. Can I do another substitution problem? Let's add another one on here. If I said 2x to the negative 4 thirds minus x to the negative 2 thirds minus 1 equals 0. So this is fairly similar to a problem you had on homework. The thing that makes this hard is the x to the negative 4 thirds and the x to the negative 2 thirds. Which of those should be my u? And here's why. If you take x to the negative 2 thirds and square it, don't you get x to the negative 4 thirds? So my problem, x to the negative 4 thirds, that is my u squared. Minus x to the negative 2 thirds, that's my u. So all that u is doing is kind of holding the place right now until I can make this problem nicer. We would need slip and slide here. Multiply to negative 2, add to negative 1 would be a negative 2, positive 1. Divide back the 2. Now what? Yep. We set this to 0, so u is 1 and negative 1/2, but then we have to substitute back. U is x to the negative 2 thirds. So I'm replacing both of my u's with x to the negative 2 thirds. All right. Several different options for how to solve from here. Any thoughts?
We could put x over 1 over x and have x squared.
So the negative puts it on the bottom. A 2 thirds is like saying the cube root of x squared. So if you wanted to get rid of that, you would multiply over your denominator. How do you get rid of a cube root? Cube each side. How do you get rid of a square? Square root with it, we do plus and minus. So we get positive and negative numbers. How could I solve the other one? Give me a different option so everybody can kind of see. Okay. This was a negative 2/3 power. We know we can add the same exponent to each side. What would happen if I did the reciprocal? Negative 3/2. Is that legal? Sure. Negative 2/3 and negative 3/2 would cancel and just give me an x. Okay, you might have to think a little bit more here. What would the negative exponent do? So it was a negative 1/2. If I flip it, it's a negative 2 to the 3/2 power. That means the square root of negative 2 cubed. Okay, what is negative 2 to the 3rd? Negative 8. Alright, can we break down the square root of negative 8? Yeah, what would it be? We also, something we haven't really talked about, this strategy, because the 2 is on the denominator, that's like adding a square root. Anytime we add a square root, what do we have to put with it? Plus and minus. And so we would need that as well. Alright. Answer turned out to be not real pretty on that one, probably because when I make up problems, they don't tend to be very pretty. But we got answers. And then could we check them? Okay, so you can use that substitution if you have a very complicated problem and you can't figure out how to solve it another way. So what I want to do now is give everybody a chance to get the help that they might need. I know we're kind of at different points. Some people are doing okay, some know certain types of problems, some of us are having trouble all around. That's okay. We're learning. There is a handout posted on Google Classroom that has practice with all these different types of problems. So that is your assignment. It's 10 questions, so nothing too crazy. You have the rest of the hour to work on it and ask for help if you need it.